All right, everybody, I think we'll get started. So welcome to the network operations session for today. We are very lucky to have Rajiv, I will get it right, from Cisco, who's going to be talking to us about playing the game and how that relates to network operators. He's dialed in remotely as he was unable to travel for the conference, so please make him welcome. Thank you.
Thank you. I appreciate that. Yeah, I wish I was there. Would have escaped the snow that we had for the last 5 hours. So it's actually the background you see is right outside my house with a good chunk of snow. So what I wanted to spend the remaining 29 minutes with you was really to talk about the phenomenon that most of you are well aware of, but may not have delved into so much. And to get started, I wanted to actually ask you to think about answering this question. Who do you think Netflix, one of the streaming giants, competes the most with? Some of you might be thinking HBO or ESPN or Hulu or YouTube or things along that nature. Well, according to Netflix, you might be surprised to hear that they believe they compete the most and lose to gaming such as Fortnite than HBO. In fact, more people watch gaming video content on the internet than all of those streaming platform I just mentioned combined. So the interesting phenomenon on the internet, as many of the operators have been experiencing, is the explosion of gaming related traffic. Now, gamers, many of the gaming customers of ISPs, they perceive lag to be the key for gaming experience. Now, we believe, based on the work we have done and we're continuing to do in analyzing that there's more to that. So in this presentation, we really want to dig deeper and give a little bit more insight and end-to-end view for operators to really benefit from this growing gaming business and the experience. So you might wonder, well, how large is this video gaming, right? Most of us have been fascinated by the video over the last decade and a half or so. Well, how big? In terms of dollars, well, US dollars, it's in 2019, it was close to $150 billion. By 2022, it's supposed to be more than $200 billion. And gaming, as many of you probably are aware, is a lot bigger than movies, the television, the music, all combined. If you're thinking about the video distribution market, right, the typical video CDN, well, guess what? Just in terms of US dollars, that's 12 billion or so last year. So that roughly less than 10% of the gaming business. So think about the size and the impact the gaming as an industry really brings into the equation. Well, many of you, I'm sure in the room, play video games. Well, if you're thinking, I don't, well, guess what? 2/3 of you in the room, and based on the stats that have been analyzed, actually play video games. Offline, online, more so online than ever before. There are different types of games, different genres and different subgenres, strategy, action, and also within these categories, there are different types of subcategories, the subgenres, right? The first person shooting, last person shooting and fighting and so on and so forth. So what, on the right side, you might be able to see perhaps, some of you think that playing games can have positive impact on our lives. Well, that can be debated, but what's not up for debate is the impact that the gaming have on the network is dramatic. It's dramatic depending on the type of games being played, as I mentioned earlier, depending on whether the game's being played, downloaded, or watched. Now, fact of the matter is the end-to-end network SLAs are really, really important, crucial to assure the superior gaming quality of experience. So let's break it down, the 3 different buckets of gaming traffic. First, well, before you can start playing, you gotta download the game. as most of the games now, for many years now, have been actually sold online instead of buying, going to a store and buying a DVD or copy. So put that in perspective. If you have been using any sort of mobile phone like Apple iOS, well, those software for iOS, latest 13.1 is like 2 gigabyte. Windows 10 was roughly 3 gigabyte. Mac OS that came out was 6 gigabyte. If you're watching a streaming movie on a Netflix and high def movie of an hour, that's 3 gigabyte. Might be thinking, well, what does that mean? Well, this is what many of operator traffic has to put up with when these new versions come out. People have downloading all over the place, so the traffic load increases. Now, guess what? If you have gaming customers that play games like Call of Duty or Grand Theft Auto, it's 100 gigabyte or more, 100 gigabyte or more. Well, and that's just the basic game, like the first time we buy. Every other week, every month, they may have patches coming out, new updates. And you know what? Many of these games patches could be more than 40, 12, 20 gigabytes, more than what it might take to download the entire computer operating system. See, some of you might have to then take a step back and wonder, if this is the amount of downloading gaming software traffic that each user could have, what would it mean if we had just 50 users, 50 gaming players in a given domain, whether it's one access domain, whether it's aggregation domain, whether it's within a specific neighborhood? If they were downloading games simultaneously like Call of Duty, what would that mean? Well, it's close to 5 terabytes worth of traffic just to download a game. And that is heck a lot of traffic, if you think about it, to facilitate the gamers to start, well, before they can start even playing the game. So of course, from the download standpoint, and we haven't even talked about playing or viewing the game, just from downloading standpoint, it becomes imperative from user standpoint to facilitate the fast download, right? Minimizing congestion. And one of the recommendations that we have made, of course, is to bring the notion of caching these software files closer to the users, whether it's some sort of edge computing, whether it's some sort of having the national data center or regional data center, becomes really, really foundational. So once the games have been downloaded and people start playing, one should make a note that this is predominantly UDP traffic. And more importantly, these are small packet sizes. So in the last presentation, some of you probably got the glimpse about the big packet size, 1,500 or jumbo frames, 9,000 byte size. Well, come gaming traffic, the packet sizes are pretty small as compared to that of typical video traffic that you may have from CDNs such as YouTube and whatnot. But the packet rate tends to be a lot higher. And these traffic characteristic is more like constant bit rate, and these are not short-lived flows like typical video traffic streams are, 3, 4, 5 minutes and we're done. But these gaming traffics are long-lived flows, could go on for hours. And what's fascinating is in a multiplayer online games, more the player in that group, higher the downstream to upstream traffic ratio. And what we have seen is that the typical traffic pattern is hub and spoke. It's not player to player directly. It's rather traffic going from all the clients to the server, and then server sending the updates back. So what happens is this packet rate, the PPS that the network has to deal with, is not that obvious to the network operator, because it's a function of really game. More specifically, that packet rate is a function of game tick rate. Tick rate is the one at which server processes all of the client's input and then generates snapshots to be sent to the client. And the snapshot rate together with the tick rate, they describe how frequently the packets are going to be sent. So the server logic typically decides these snapshot rate based on the clients, your customers, the gamers, network conditions, for example, bandwidth that they have available, latency, jitter, and so forth. Now, these PPS, as you might be thinking about, are not the same for upstream and downstream. They tend to be different. What we have observed in many of the games, in the upstream direction, the typical packet size in the upstream direction, 90% or so of the packets would be less than 100 bytes. That's a typical packet size for upstream. You know why? Because all our client is sending once the game has been rendered the first time is really the clicks, right? The action that we are executing while playing a game. The downstream directions tend to be a lot bigger. We have seen anywhere ranging from 50 bytes to 900 bytes for a few of the games we have analyzed. But 90% of the IP packets in the downstream direction tend to be less than 500 byte size packets. So it's very important to put this all in perspective as we start to think about making the gamer's experience better. So if you think about policies, right, QoS policies in the network, most of the networks have a lot more TCP-oriented policies, or have had. Of course, this has been changing, of course, for last year or so, as more and more traffic is being, at least on the Google side, is being sent over UDP. But what I and many of us have been finding, the networks are not optimized for handling UDP traffic. Unfortunately, UDP traffic happens to be a lot more on the DDoS type of side, meaning many more networks actually police UDP traffic, and that's not necessarily good for gaming traffic. And the gaming traffic demand a lot more PPS-centric design and consideration than BPS, or bits per second centric. The utmost important part is really the latency and jitter. They have to be a lot more deterministic. What that really means is that as we start to think about how the games are getting played, the actual quality of experience from gamers' point of view, that many of you, if you have been playing games, or if you have friends and family members playing games, you would hear this word lag. And many of them, or many of us in the networking construct, think of that being latency. But what that really means is quality of experience, which is back to same set of SLA consideration, drop jitter, latency. And it's important that latency is not that big of a problem, contrary to what you may have been conveyed for gaming's superior experience. Why? Because most gaming engines, and there are many of them that out there in the wild, whether it's Riots, whether it's Take-Two, these gaming engines have gotten very sophisticated in handling and accommodating the disparity in latency among users. And they have these really fancy lag compensation algorithms with machine learning to handle this disparity, latency disparity among gamers. So I could be 30 millisecond away from the server. You could be away from 50 millisecond. You could be 50 millisecond away from server, and so on and so forth. That is not an issue for most of the gaming engines. What becomes a big issue is the jitter. So if I'm 20 millisecond now at time t, and time t2, I am 80 millisecond. So boom, jitter got introduced. That's what these lag compensation algorithms struggle to cope up with, and that's what causes the problem. So what you see on the bottom right side is a representation of a player running, and you see blue and red, right? So when what a player is seeing its own representation versus what other players are seeing, that representation versus what the server is seeing, that representation gets impacted a lot more by jitter. So what you see on the red is what when the server would have calculated versus what other players may have seen. So the common question that comes at this point of time is, geez, what's the typical jitter? Well, 0 is the right answer. What's a typical latency that most gaming engines are good to work with? 90 millisecond or less, 30 millisecond to 90 millisecond, that's usually all reasonable. Of course, less than 30 millisecond, that's excellent. Now, this is again between the client and the server, not client to client. That's the latency we're talking about. So what that means from the network point of view really is to be able to offer sophisticated or deterministic quality of experience, deterministic SLAs to ensure those the gamer customer's experience. So while the game's getting played, here's an amazing phenomenon has been taking place, and some of you probably are aware of this, that the games are getting watched online in real time. And that is the second most popular thing on the internet, with 200 million plus, and this number is probably not dated, maybe 250,000 plus, watched the game viewing done daily. And just on YouTube, the numbers we got is roughly 15 to 20% of the viewing hours on YouTube is related to the gaming content. So if you think about that, the gamers, and this is just, by the way, the high def, right? So ultra high def 4K being utilized by many gamers to broadcast themselves becomes another quite a bit of contributor to that network load. See, now you might be thinking, geez, what would happen if just 1,000 users viewing the game, 1,000 users in a given network domain, could be an access, could be a neighborhood, could be an aggregation network. That's close to 5 Gbps, 5 gigabits per second worth of traffic load if viewing in high def. And if that was in 4K, ultra high def, that will be 25 Gbps. That's heck of a network load, right? If you think about from just the viewing perspective. Now, some of you might be thinking, well, geez, what if I got number of users downloading the game, few of those users playing the game, and a lot more users viewing the game at a given point of time in a given network domain? Pick whichever network domain you could think about, from access through backbone to peering. That adds a lot of network. But what is extremely relevant point to highlight is that the quality of experience expectation changes based on whether the games are being downloaded versus played versus viewed in real time. So the typical consideration you could expect here is to really minimize the congestion in the downstream direction. That's really, really, really important. If you start to think about, these considerations from the network point of view, well, now the fact that there is also a home domain, home network that in some cases operators manage, in some cases operators do not manage. In some cases, there are third parties that do manage. There are a number of interesting things that happen in the home domain that can impact, make or break the quality of experience of gamers. In many occasions, gamers who are not professionals, they would firsthand think if something is going wrong, call the ISP. Call the ISP and blame the ISP for that below par gaming experience. What we have realized, and many of you probably are well aware of this, wired versus Wi-Fi can greatly impact the overall throughput in terms of the actual gaming traffic when it's being played. And when it's being played, jitter can come in very quickly if it's over wireless, especially because of the interference that can come in and go away at different points of time. So a lot of gamers who are well aware of technology, they tend to not have Wi-Fi be connected to their gaming consoles or to their computers when they're playing games. Of course, there is always a preference for wired. There's also preference for using 5 gigahertz or higher. So on the next slide, I'll touch upon some of these recommendations in terms of different network domains. from the ISP point of view, from the operator point of view, what makes the utmost difference in our analysis is really the access domain, because of the sheer fact that the access domains are typically heavily oversubscribed. So the oversubscription with results in congestion, which results in more other challenges. Backbone and aggregation, usually not much there to optimize, given that these are a lot less oversubscribed in general. Of course, there are exceptions that could break that assumption. The second domain that is a lot more pertinent is the internet, the peering points. That can also make or break quality of experience. In fact, doing some work with a few of the cable operators here in the US, we have learned that even though they have done an amazing job inside the network from access up to the internet handoff, because the way the peerings are done, and many of you probably well know that peerings are not done based on gaming traffic, rather they are done based on cost optimization and so forth, right? Traffic levels and so forth. So from the gaming point of view, the peering can make or break that experience. Now, there are few of the niche players out there that try to figure out, and in fact, we are also doing some analysis, working with some of the operators, which peering points and connections between the ISP network and the gaming server, whether the gaming server is hosted on a private cloud, like Riot does, it has its own network, whether that's hosted in a public cloud, like some of the mobile video gaming companies have been doing. Once the traffic leaves that boundary, that domain, and it's on the internet, nobody knows what path it takes. So we have been meaning to analyze the different paths that might exist, and the SLAs that might be presented by those paths on the internet between the ISP network, the peering points, and the gaming server location could actually give us a lot more insight that can help us eventually to make some sort of overlay-based decision for optimizing the gaming traffic on the internet. I mentioned this home network, prefer wired versus Wi-Fi. Consider something like dual channel Wi-Fi. I'm not sure how many of you are familiar with dual channel Wi-Fi. That was a specification has been published 2 years ago by Cable Labs, and there are different implementations that are coming along. Essentially what that does is separates transmit and receive for the Wi-Fi, and almost all the Wi-Fi implementation that we have around the world are single channel Wi-Fi, meaning single channel use for transmit and receive. And of course that doesn't necessarily yield optimal experience for the gamers. From the access network point of view, I'll touch upon two of these specific recommendation, and that is first to keep really the access plant clean, especially if you're using some sort of RF in the access, very, very important. Whether it's dirty fiber, whether that's power levels, and things along that nature. Definitely consider reducing congestion, whether that's taking a different split ratio, like node splits, whether it's in the PON, whether it's on the DOCSIS cable side. It's really important in that consideration. And you might be thinking, well, how big of a difference does that make for the actual gaming traffic that's resulting as playing a game? Not much yet, until cloud gaming comes along. What Stadia and some of those, and Microsoft has been trialing with. If they really take a lot of foothold on the internet and the gaming community really picks it up, that's gonna increase the data rate for actual gaming traffic as well. But until that happens, here the congestion would really be about when the games are getting downloaded. I don't know how many of you caught up on the Nanog list. A week ago, was it last week? I think a lot of operators notice a big spike in the utilization, like all the 10 gigs and 100 gigs are getting overfilled. Why? Because, well, Call of Duty, I believe, came out with their patch, and off that went. Peering, I mentioned, if operators have really significant number of gaming players, or if the intent is like some of the operators in the US are doing, they're going after their gaming customers, giving them a prioritized service for $5-10 extra dollars. It's very important to analyze and optimize the peering relationships that's centered around gaming service. Now, many of us have well heard of exchange points, internet exchange points. There is no such thing yet as gaming exchange points. There are few who are starting to look into exchange points that would be centered and optimized for gaming traffic. So the recommendations go really far in ensuring the gamer's quality of experience. The other thing also that becomes important is really that the ISPs can directly partner with the gaming publishers, right? This is more of a B2B. And you might wonder, why would that be? Well, there are multiple different benefits. Today, what we have heard over and over, and many of you could probably relate to it, anytime a gaming customer, well, an ISP customer playing games experience lag, first thing they do, call the ISP, even if it has nothing to do with the ISP network. So by having these hooks into the gaming, and there are few out there who are actually doing this, putting their hooks into gaming SDKs, they have a lot more visibility. So when the customer calls and it says, all right, for these specific gaming titles, now we can actually have a lot more insight for this specific set of users that we can now help them address. Second, of course, a better quality of experience in terms of prioritizing the gaming service flows. One of the difficult things today has been to identify gaming traffic that is important. There's no reserve ports like for VoIP. There are many well-known libraries that have the UDP ports being documented, and typically those who want to prioritize VoIP traffic could do so, like FaceTime. They've well published the UDP ports that they utilize. And that's not a huge range, that's a small range to work with. So that's another avenue for operators to really provide managed gaming services. Before I conclude, I want to touch upon the cloud gaming, because while that's not so common today, it's going to impact and increase that load on the network. It's going to impact the network exponentially. And many of you probably are well aware that cloud gaming is intended to disrupt the entire gaming industry. Why? Because there's nothing to download, there's nothing to apply patches, none of that. The whole model gets upside down with it. If you were to think about how much traffic it would be, 7 gigabyte per hour of a 4K movie, if you're watching Netflix on the right side, well, if you're playing a 4K game, that's two times of that on a per hour basis. So think about the load on the network. And this is single player, by the way. So if you have 50 users playing a game in 4K from Google Stadia or Microsoft's Xbox that is going to be coming online as a cloud gaming as well, that's going to increase the load on the network significantly, more so than ever before, right? So it's really, really important to put that in perspective as well. So I want to quickly conclude and just bring that to your attention that video gaming is one of the largest businesses on the internet, and the quality of experience for gamers, for operators, customers, is really a multi-domain puzzle, though some domains are more important than the others. And the lag is not just about latency in their construct. It's rather the entire quality of experience. And what ISPs can do to improve their gaming customers' experience is a number of things. ranging from employing these cross innovations to having bandwidth reservations to having some sort of B2B relationship with publishers to caching the gaming content. So with that, I would be open to question and answers.
Thank you very much. Is there any questions? No questions? Then we'll say thank you very much to Rajiv. Thank you very much.
Thanks a lot, guys. Appreciate that.
Thank you. Really appreciate you calling in. Alrighty, up next is Aris, who is an ONF ambassador, and he's going to be talking to us about Chord, and please make him feel welcome. Thank you.
Okay, good morning. I'm Aris. I'm here speaking as one of the ONF ambassadors. Today I want to share about one of the open source project from the ONF. Basically, want to help the service provider to transform the network. Actually, this term is already introduced from the previous speaker in the previous sessions from Telstra, that we all know that the service provider needs something to transform the network. Okay, so as introductions, because it's ethnic event, so I want to take some presentations from the very famous ethnic fellow here. The presentation is very long, so I cannot explain one by one. Maybe you can check directly with some of the presentations and also recording video for these presentations. But what we can learn from this presentation is our internet has been changed. So he mentioned that this is the internet in the 1990s. So where the upper tier of ISP will get some benefit from lower tier of ISP. But now the network is changed. So you can say like the access ISP, which is in the network in the lower tier, they just need to connect to the CDN, right? It can be any OTTs like Google, Facebook, or any other OTTs. And then if you compare these two, you can see like network is totally different. Okay, sorry. Okay, the first one is mostly like small number. You just count the number of the OTTs. And then most of them like use the open solutions, but they did very highly customized solution. So it is very hard to operator to follow their effort. And then the end of the day is homogeneous because they only taking off or their own services, no other services from other providers. Then if you talk with the access ISP, you talk with the huge number of operators, can be hundreds or maybe thousands. Most of the solution is standards, but because of sometimes they just bought from the vendor, sometimes it's become proprietary. And the service is, in terms of service, is heterogeneous because they also need to taking care of another services from other customers. So this is the two, I mean like the difference between the two networks. So in that case, ONF try to help especially the provider, which is in the access ISP, how they can transform the network by learning or adopting the solutions from the, you can say like the CDN. Okay, so the release open source is called like CORD. As I mentioned, the original word is like central office re-architect as a data center, which is we want to build a new platform for the new network age. So the idea is pretty simple. If you can see, there is central office in the telco operators, okay? And then we just want to change this one into the edge cloud. As some previous speaker like told about, we need to transform the what they say like the CO into the edge cloud. It's very important. Why? Because to reduce the latency, as the previous speaker mentioned about we need to reduce the latency for the gaming and other things, and then the power issue, and then to add more capability for the computing processing. So this is very important. But the important is how we can change transform this central office, legacy central office into the new platform. So by using the available technology that we have today, like SDN, NFV, or cloud, we can make a platform. You can say like this here is the edge platform that can manage all the different devices for different access types. Like you have Metro E, you have PON, you have what they say like RORDM and all those things. Because by the end of the day, the platform should see all the devices is just like programmable switch. Okay, so the platform just need to see this device as a switch. And then they control based on the, what they say, like the forwarding policy. Okay, and then if you have this platform, so you can build many different services depending on who you are. So it can be like mobile operators, or it can be enterprise operator, or also maybe like the fixed network. So you need to provide service to residential customers. Okay, so in the high-level view, or in the what they say in the real scenario, okay, so you want to transform your large number of central office, which is usually is very old, and then consists of many different equipment for different type of access into this kind of architecture. So you will have the commodity hardware from the data centers, from the data centers solutions, and then you need some interface to the access to your subscribers, and then you need to have some device or links to your upstreams providers. Okay, so and then inside the data centers equipments, what we can see here, like everything is just a switch. So depending on how you program, it can be used for different type of access. Okay, and then in order to provide some high availability, you can enable the what we call like fabric based on the SDN, or very famous now, like somebody say like close, or maybe like leaf spine fabric, and then it controlled by centralized controllers, and then together with the like the network controller or SDN controller, you have orchestration systems, or maybe orchestration platform that you can manage all your services side by side with the network controller. So why we need to do this? Because the most important, like you will have the economy of the data centers, because you can use the white box for deploying your infrastructures, and you can also adopt some open source software for it. And then of course you will have the agility like like the cloud provider have, because if you talk like many different OTTs, they can roll out or change the software. It's not in the years, but maybe it can months, or maybe less than that. And then if you can move to the, what they say, like data centers or maybe the most close to the cloud, so it will be easy to make some APIs or what they say, another solutions that your customers can access to your platform directly. Okay, so this is something that we want to achieve. So we will have this, it's cloud based on our platform, it's core. And then as a components, I know it's very big, what they say, like open source project. So we need to break down into small components, which is also become another open source project. As we can see here, we have in the right-hand side some components that need to talk with the access network. So you can have the Metro E, GPON, or RAN or whatever. So in this case, we have another open source project for this one, but it will be in the different discussions. And then you also have some components that need to talk with your upstream providers. It can be fiber or it can be any connections. And then in order to connect between these two, you need to have something in the middles. Usually you use the switch or maybe like the you can say like fabrics. And then inside that one, you need to have some software loaded. And then of course after everything is ready, you need to make some example of services that you can what they say prove or show to the customers that you can run many different services in the same platform. So today we will discuss only the what they say in the middle one. I mean like the how you can make this connection inside the data centers and then connect with different type of access network into your upstreams. Or even how if you have some local processing in the data centers, it can be done using the Trellis platform. Okay, so Trellis is open source multi-purpose leaf spine fabric. So as I mentioned before, it can be used for any different services. It's not only for the switching L2 switch, but it can be also for the what they say MPLS or whatever you want. So this is the overall architecture of the Trellis. So as I mentioned before, that the ideal topology is only leaf spine fabrics. So you will have the leaf switches in the below, which actually you can connect either some compute nodes or you can connect to the access nodes, which is it can be what they say, it can be radio, it can be GPON for the residential or whatever. And then we also have some switch that connect to the upstream routers using the L3 connections or some other methods. And then of course you will have a spine switch that used to mix them up, I mean all the traffics. And then if you really need some applications, so you need to push it from the SDN controller in the top of it. Yeah. So the basic tenets of the Trellis should be SDN based and use a white boxes, and then of course it will be open source. Okay, if you look on the details, I mean closely how the Trellis component is developed. So we have two different like components. One is a component which is sitting on the centralized what they say, the location, which is in the controllers with some Trellis applications. And then you have some component which is also open source inside your devices. This is, for example, we have what they say, the open source software, small open source software for from the Broadcom in order to support the Trellis project. So why we use a Trellis? Because as we mentioned before, it's specially designed for service providers, and then we use the SDN to simplify and optimize the features. And of course, if we talk with SDN, before we only talk with, we are using the open flow, but now with the new paradigm come, it's like P4. So we also use the P4 as like southbound API to enable more features. And then of course it's open source. So you can even you can take all the codes and then you can develop by yourself, or even extend some features that not available in the basic release. Okay, this is the reason why it's optimized for service providers. One is whatever type of traffic, so you will just go to the switch. For the point of view of the Trellis applications is, the something that come from the subscriber is only the switch. And then the switch itself can be any vendor who support the open source white boxes. So, and then the third one is we can also extend these solutions. It's not for the central office, but you can also use it for the field office also. So this is the reason why it's optimized for service providers. So this project is not only owned by ONF, so it has been initialized and then supported by many different providers. Some of them, some of them maybe is already in this community, but of course you feel free to check the details of the project, and also try to check whether you have something that you can contribute or get in touch with us. Okay, last year in ONF Connect US, Elaf Nafsi from Comcast, they launched a press release that they were able to run the first Trellis open source in the production network. Yeah, but this presentation is very long, so it's like around 50 minutes, so I cannot summarize in here. But you can, this is some links that you can try to open and then check the detail of the presentations. It contains some, motivations, like the problem iteration and all those things. So maybe you can learn from them how you can run the open source in the real production network. Okay, and of course this is not the successful story from Comcast. It's more than Comcast successful story, because is work from different communities. And you can see here there is a vendor from Broadcom, Sienna, and EdgeCore, and also of course from Comcast itself. And then there is Infosys as a system integrators, and of course the ONF as one of the you can say like the steering committee, or maybe like the technical decisions how the Trellis open source software will move forward. So you may check the details on the presentations. So I cannot answer for the detail for the deployment. So if you want to have some questions for the detailed deployment in Comcast, you may check with this guy from Comcast US. So he asked me that if any questions regarding the deployment, you may check with him. Yeah. So you please feel free that you can contact him directly. Okay. So any general questions, I will be happy to take it. Thank you.
Thank you very much, Aris. Any questions for Aris? Okay. Can you come to the microphone in the middle and just state your name and where you're from, please?
I'm Amin Dalali from MBN. Just wondering, the list of vendors that you provided, do they provide commercial solutions which are commercially available, or this is a trial? The reason that I asked, the context of my question is that what's in this? Like, it makes sense for operators or service providers, but I don't quite see commercially what's in this for vendors. Because they lose their market.
Yeah. Some of the devices from the vendor is already commercialized. For example, like from Broadcom, they have already the chip that support the what they say like the Trellis, and even from the edge core, they also have from the Trellis. So, but the idea is they don't really push their own solutions, rather than they work together with the operators to know what is the operator needs for their services, and then they will try to what they say mix the either software or customize on the hardware to meet your requirements. So it's not just vendor selling the white box and then doing nothing. No, it's something that you need to work together between operators and the vendors. Yeah.
Hi, John Brewer. I've had the privilege of rolling out a lot of equipment to telco central offices, and in my experience, they've never been compatible with high energy draw devices like servers and close architectures and all of these wonderful things you're talking about putting in a central office. And in fact, in New Zealand, a lot of the big COs have run out of power, and so access seekers are having to haul their interconnect traffic to suburban exchanges just so they can pick up 10 gigs of customer traffic. Do you see this sort of architecture working at any existing central office in any telco in the world, or are people going to be building new central offices?
Yeah. You may check with the detail from the Comcast. The most of the deployment actually is not just replacing the old one. No. Basically, one of the example, if you want to have some refreshing your hardwares, instead of you are buying from the what they say like the proprietary vendors, you can approach some open source solutions, and then you make the trials. It's not just okay. Now we have some upgrade. We dismantle this one. We need to replace with this one. Actually, some of the deployment will not doing like that. So they will just do some what they say any chance for the upgrade, small upgrade. They will try with the open source solutions, make it as field trial for a couple of months or whatever, before they launch as like productions. Yeah. Because this even the Trellis is already released some years ago, but finally the production grade of this open source is just released in last year. So of course it need sometimes to make it matches, but by doing the field trial or maybe like small scale productions testing, it will be very useful. Yeah. Okay.
Any further questions for Aris? Going once, going twice. Thank you very much, Aris.
Okay.
And finally, for the last part of our session today, we have Gyanendra, who's going to be talking about operational deployment of broadband. Please make him feel welcome.
Good afternoon, namaste, and warm greetings. I'm Gyanendra Maharjan, and on behalf of ICT40, I'm going to present presentation on operation and deployment of broadband. So let's get started. Center for Information and Communication Technology for Development. So basically the core value is ICT for empowerment and development. Our mission is ICT for development and empowerment by the community, for the community. Vision effective uses of ICT for socio-economic development within the PPP model. Our objectives are research, collaboration, applications, assistance and training, advocacy. PPP model for effective uses of broadband, beginning of a new deployment mode. So, okay. In Nepal, this is the current status of have a gathering. I mean, so this is current coverage, broadband wire 13.7%, fixed broadband wireless 0.82%, mobile broadband 52.71%, need to be connected broadband internet approximately 45% of population, no mobile coverage 69 to rural municipalities, no broadband coverage 150 local governments. Broadband connectivity is now being provided from NTA RTTF fund to the provincial and municipal connectivity packages, medial highway packages, projects, municipal offices to support public schools, health posts, and of course there's a ISP initiatives. Broadband penetration hurdles for those rural area to be connected, it's like quality of service, speed, uptime, availability, operation and maintenance, post-implementation, weather, geographic, and effective community participation. Project delivery takes time to coordinate between multiple departments, example, roads, environment, and of course the NEA and poles. Project background, basically we have done the project to the APT, Asia Pacific Telecommunity, to the mid-far west part of the Nepal region. So and it's a Dulu municipality, Dailek area, Kanali province. Dulu municipality consists of approximately 5,900 households with a population of approximately 45,000. Even though it has been declared a municipality, Dulu lacks a modern and robust communication network, and its development indices, health, education, etc., are one of the lowest within Nepal. Prior to the project design, the team interacted and did research on the requirement of the community. The project primary focus of network deployment and providing internet operation through efficient and sustainable systems and process. The project provided e-government services and telemedicine services over the implemented internet. Local community infrastructure. So it's a silent features that we did a project. There is a municipal-owned broadband backhaul-based ITT standard L.110 OFC cable, hybrid network OFC and wireless, and services is a citizen-centric services, collaboratively rural health care delivery, e-governance applications, early stage of online learning resources, and digital Nepal, effective when it reaches out beyond urban centers. This is the architecture that we have made with this optical cable as well as wireless connectivity. And here we can see the 13 ward offices are connected, 1 hospitals, 4 schools, and probably the only municipality in Nepal with the own its internet network is a Dulu municipality. Our participations support municipality to build infrastructure as they develop in smart city to enrich service delivery mechanism of municipal through the uses of ICT service and applications, to support municipal initiatives to provide ICT for education, health, and agriculture services, awareness among citizens on effective use of ICT, empowerment of local resource persons on network operation and maintenance, technical and operation consultant for designing PPP model of sustainability of the project. So this is a Google overview of this network. You can see this is a fiber optic cable, 12 kilometer, and these all are in the, this terrain is a geographic terrain, is so difficult, this area. These all are wireless. So network deployment. So we have analysis first before the deployment of this technology, right? Talking about the analysis, deployment area understanding is most important to ensure compliance and fit with the type of technology. A limited number of electricity poles for aerial optical fiber cable support, weather, wind speed for the wireless, lightning, etc. And in depth analysis, we evaluated the viability of the different ITT standards cables for different types of aerial OFC deployment. Then we figure out with this optical cable, ITT L.110, so which burial cable DIY itself, so that the community can easily draw the fiber cable in this terrain. And then we have made the point-to-point wireless connectivity, 5.8 gigahertz, to connect the last mile connectivity. So talking about terrain and weather, our analysis on the type of amount of precipitation was carefully analyzed. The cable selection process was informed by that. Weather condition, wind, rain, soil, erosion part has a direct affect the rate of cable layout, type of machinery used, and type and quality of the packing soil. The packing soil was used to cushion the OFC after the replacement of native soil, and hence was transported from the nearest river bank, where sand mining was legally permitted. During the pre-monsoon months, the heat from traveling in front the Indian Ocean lead to the much lightning, which precedes the inundating rains during the month from the July through September. Hence, the team had to evaluate electrical grounding system and technologies that would be best suited for such an environment. And on economics, the team evaluated the necessity of various interaction with local elected leadership, members of civil society, and the past and current implementation from various domains, water, electricity, etc. The legal implication of various aspects of value-added services and other legalities were evaluated. Example, type of education and medical services that are delivered over the network. These are the glimpses of the project. We can see here, this is a 2-kilometer fiber optic cables, and these are the wireless connectivity, difficult areas. And this is an internet operations, network development. We have made the 13-watt offices to be connected with this fiber and wireless connectivity. So there are two major intervention modalities. One is business management, necessary to initiate, maintain, and build confidence with local residents, local governments, and civil societies. Training to address local professional development, be part of local business incubation systems process to ensure long-term viability and uses of network, create local ecosystem that will potentially use and deliver service over network, ensure value-added services locally. Technology intervention, scripted device installations, remote reboot, fault error detections through CACT, NAJOS, MRTG, etc. Implemented light-out management LOM to ensure minimal physical presence in project area data center. Remote login by project implementation team, only when necessary to support local technologists and enthusiasts who are currently volunteering. Some of the glimpses again for the internet operations. These are the small, we have a router and switch, fiber optical switch. This is a power level with these fiber opticals, and this is the connectivity details. So this is a power backup. Digital Nepal initiatives. Basically, if we talk about digital divide, actually the connectivity which we are thinking of, the new technology which is going to connect the rural area is totally different that we analyzes there. So that means like what is the requirement of the that local community people to get connected and everything. In policy should be depends on data-based evidence, not just from the online tool, example Google Earth survey, on connectivity, content and quality needs to be evaluated. Community participants are interactive with relevant content and applications. Digital divide must be addressed through multi-faceted action intervention. SDG, domain of education, health, agriculture, energy, finance, urban infrastructure, tourism, financial services, and connectivity need to be national policy priorities underpinned by digital technology and allowed to grow with penetration of ICT. Participation and sustainability, I said for the team ensured about the participants through honest and sincere interaction, managing expectations, provide training, demarcating responsibilities, oversight and audit, and on the part of the sustainability, local inclusion of course important, empowerment, participatory approach, community human resource, implementations is conditionals. Again, there's some of the other the same project pictures. And these are the finding of the ITT standard cable, which is we can easily bury, so we don't need a docking cable there, right? So that the local people also can use by themselves. So this way, this project is viable there in such a terrain. Okay, there's a 3P about the public-private partnership, which is very important to sustain such a project in such a rural area. So public for Dulu municipality, responsible for local human resource, local transport, machinery, bureaucratic/policy level support. Private, IC40 not-for-profit, domains of technical expertise, organizational, management, support, partnership, the delivery of citizen services, ongoing work in progress. A rural connectivity project. So expanding network connectivity is a necessity, but not sufficient condition to leverage ICT services. Forward-looking institutional arrangement, example PPP, community cooperative, local enterprise, leasing, etc., to be further explored. E-governance must be central to connectivity projects. Reinforce, encourage, fosters the business environment for digital economy through effective and affordable use of technologies and data. And of course, the citizens-centric services through appropriate application, example, health, education, transportation, agriculture, commerce, and more. Thank you. If you have any questions.
Are there any questions? No? Then we will say thank you very much.
Yeah, thank you.
Thank you.
And I would like to invite everyone. In Nepal, this time there's a APAN 49. It's going to held from March 2nd.
Thank you. So that concludes the network operations section for today. I believe Aris has some stickers for those who would like some cord stickers. Otherwise, thank you very much and have a good afternoon. And enjoy lunch.